Hello, good morning everyone. Hey, what's up guys? Am I audible to you? Guys, am I audible and visible to you? Okay. Guys, share your attendance once please. Like Shillong doesn't say good morning, they simply put their attendance on the screen. That's it. Good morning. I'm too good. What about you? How's life going on other than the studies? Is everybody joined the class? Or still some are left? Oh, it's raining. Good. Oh, so guys, any update for me? Anything new? Anything interesting? Okay. So guys, is everything going on smooth? Hey, good morning, Senapati. How are you? What happened here? Okay, so first few minutes for you guys. Tell me, what's your problem? I mean, let's try. If I'm able to solve that. Please don't say that I don't want to study. And first of all, tell me that how many of you have started the sheet that I have posted in the group? Have you started practicing that? This is the question. So you're worried about this question only. See, non-metals means those species which has tendency to pull the electrons towards themselves. Okay? And ionization energy is what? That tendency to lose the electron. Okay? Okay, so first of all, let me clear your question, answer to your question, then we'll switch to the next question. So, obviously, the amount of energy you supply to release the electron is known as what? Ionization energy. Okay? And the energy which is released, or we can say energy change during the, we say electron gain is known as what? Electron gain enthalpy, and which is related to what? Non-metallic character. Okay, so we can say that if a species has a higher ionization enthalpy, or we can say higher ionization energy, so its non-metallic character will be very high because it has very high tendency to pull the electrons. Okay, so they are related to with each other in this manner. If higher ionization enthalpy, they should have the higher non-metallic character. Okay, so I hope so you have got the answer for your question. Now there is another question. Okay, why you don't get the much time for the studies? Most welcome, dear. What are you doing in your spare time, your free time? I guess so everybody is here just for 4 hours for the classes. Other than that, you have got enough time to study. Then why don't you utilizing your time? Guys, you can do one thing. Okay, first of all, I think so there is a problem that we are not in habit of sitting. I guess so this could be one of the problems. So I have given you that sheet. Okay, even you can do with the other subjects as well. In the sheets, I guess so there are 109 questions or 104 questions. Okay, so you have to just make a habit that you have to attempt 20 questions per day from that sheet. Okay, minimum 20 questions per day. Okay, initially you will find out that it is little bit difficult. Okay, but I'm giving you very least target, 20 questions. Okay. Oh yeah, this could be one of the point that most of the times is wasted during the travel time from coaching to center and center to coaching to home and home to coaching. Yeah, that could be one of the valid points. Guys, see, this is the situation in which we are. Okay, so we cannot avoid that. That is the scenario. We have to work in this. Okay, this is the truth. Okay, so if you know that your time is wasting over there, so leave that time. Okay, or try to utilize your time which is available to you at your home. Okay. Yeah, I'm getting your words, dear. Okay, so this is a kind of issue. Okay, and we cannot avoid that. So I would suggest that try to work in the remaining time. Okay, try to focus on those topics. Okay, ask your teachers that which topics are much more important, and make sure that the section which is being covered in your classes should be clear to you. It means that whenever someone asks any question from that topic, you are answerable to them. Okay, and I have told you to practice question papers of NEET previous years. I don't think so that any one of you has prepared a schedule that sir, on that particular day we will solve that question paper and we will share our results with you. Chemistry results. I'm sure about it. Okay, so guys, please do that. This is just for you. And second thing, the topics we have already covered. Assignments I have already shared with you. More concept I'll also share with you. Okay, so make a schedule 20 questions per day, and then proceed. After some time you will feel that see, minimum 20 questions, and after that you will feel that after some time, after 15-20 days, that you are habitual. Okay, and obviously you will improve upon it. So after all this, let's begin. First of all, tell me that how many of you have revised the topic that I have taught you in the previous class? Okay, tell me the topic that we were discussing in the previous class. ISO diaphragm. Okay, ISO series has been completed, and I hope so everybody is clear with the topic that I have discussed in the previous class, till the previous class. I'll start with the question, guys. So this is the question time. Okay. All the best to everyone. Let's see who will solve first. This is the question. Select the isoelectronic set. Option A, Na plus, H3O plus, NH4 plus. B, this is small a, this is small b. CO3 2 minus, NO3 minus, H2 CO3, C, P3 minus, HCl, C2H5 negative, PH3, D, F minus, neon, and Na plus. These are the pairs, and the options are first of all, copy this question. After that, I am giving you the options. Okay, so options time. Option A is A, B, D. Option B is B, C, D. Option C is A, B, C. And option D, E, A, B, C, D. These are the options to you. And okay, do this. Please share your name as well. CC. Okay, Balajit Kane has got the answer. Nitish has got the answer. What about other? Senapati, Itanagar, guys, what's going on? Tell me the answer. And what about others at the Shillong? Okay. Who has got D? Can I start if you have attempted that? Okay. Okay. See, three students has given me answer A, B, A, C and D. Only B is left. Who is voting for the B? I need one more. Who is voting for the B? Anyone? No one is voting for the B. Wow. Okay, so let's begin finally. Now guys, your face should be in front of, that should be focused on the screen. Okay, so let's begin with our solution. Look at this. Okay, in the option A, in the set A, okay, good. Okay, so let's start. I was just kidding. Okay, so sodium has got atomic number 11. So 11 minus 1, 10. H3O positive, 8 plus 3, 11 minus 1, 10. NH4 positive, 7, 4, 11 minus 1, 10. Okay, they are isoelectronic. So option A, has the pairs of the isoelectronic species. Let's start with the B. Carbon is 6, oxygen is 8. So 8 3s are 24 plus 6, 30 and 32. CO3 2 minus has got 32. Here 8 3s are 24 plus 7, 32. Then 8 3s are 24 plus 6, 32. B is also isoelectronics. Okay, so first of all let me check out the options. So AB is present in A. In B there is no option A, so B is absolutely wrong. Okay, try to eliminate. Okay, B option is wrong. Then ACD is left. So let's see. We need to solve everything. Phosphorus. Can anybody please tell me what is the atomic number of phosphorus? What is the atomic number of phosphorus? Is it 15? Phosphorus is 15 plus 3, 18. Chlorine is 17 plus 1, 18. Carbon is 6 to the 12, 13 and 5, 18. Wow. C is also isoelectronic. Let's check out the last one. Fluorine is 9 plus 1, 10. Neon is 10. Sodium will be 10. Guys, option D will be the right answer. Who has got the option D? Can raise their hand. I can see student of, I think there are 5, 3, 8, 13, approximately 17 or 18 students in a class. So is that section A or B at Shillong Center? The class where approximately 18 students are. Okay, that's good. So you can raise your hand. Who has got the right answer? The students who has got the right answer. Wow. Okay. So this was the question. So let's begin with the new topic. The new topic is electromagnetic waves or electromagnetic radiations. So guys, this is today's topic, that electromagnetic waves or electromagnetic radiations. Okay, so what are the electromagnetic waves and electromagnetic radiations? See, this theory says that energy from one body to another body can be transferred in the form of waves. Okay, it simply says that energy from one body to another body can transfer in the form of waves. And whenever we talk about the electromagnetic waves or electromagnetic radiations, so these are those waves, or we can say those particles which has electric field component and the magnetic field components. Okay, so any wave or any moving charge particle will have, if any moving charge particle has electric field component and the magnetic field components, then they will be termed as what? Electromagnetic waves or electromagnetic radiations. Okay. So at the time of Maxwell, this theory was designed, as he said, he simply explained that whenever a charge particle accelerates, okay, it has electric field components and the magnetic field components. Okay, and these fields are transmitted in the form of waves. Those are known as what? Electromagnetic waves or electromagnetic radiations. So we have simplified that statement, and after simplifying that, we will simply say that any wave that has electric field component and the magnetic field component will be known as what? Electromagnetic waves or electromagnetic radiations. Okay, is it clear to everybody? I'll start writing definition of this one. Do you get the statement that any wave, or we can say that energy transferred from one body to another body in the form of waves, okay, and these waves has electric field component and the magnetic field component. That's it. Okay, so let's begin. When a charged particle accelerates alternating electric and magnetic fields are produced, and these fields are transmitted in the form of waves known as EM waves or electromagnetic radiation. Please copy. Okay. So guys, the simplifying definition is this, that a wave which carries the electric field component as well as magnetic field component will be known as what? Electromagnetic wave or electromagnetic radiation. Okay. So the next point in this one is, they do not require any medium to propagate. Okay. Next, electric field component and magnetic field component are perpendicular. Guys, this is the symbol of perpendicular. Okay. This T, this or reverse T, मतलब उल्टा T जो है यहाँ पे. Okay. This is what? Symbol of perpendicular. Perpendicular. Are perpendicular to each other as well as perpendicular to direction of propagation of wave. Please copy this. Okay. So guys, let's make it clear a little bit more. Okay. So guys, first of all, look at me. Okay. Look at this one. Are you able to visualize this? See? See, this is a thumb and these two are fingers. See, this thumb is perpendicular to this finger as well as this finger. Are you able to visualize this? Have you heard about the Fleming's right hand rule? Fleming's right hand rule in physics. We do these kind of things. Okay, so look at this. See, this component is perpendicular to this one as well as this one. If I talk about this component, this is perpendicular to this one as well as this one. If I talk about this component, this one is perpendicular to both of these. Okay, so actually these are axes which are mutually perpendicular to each other. Okay, so what this theory says, if one component carries the electric field, the other two component, means out of other two components, anyone could carry the magnetic field, whereas the third component will have what? Electromagnetic wave. Can you hear me? Can you hear me, guys? Shillong? Hey, Shillong. Is there any problem? Now am I audible to you, Shillong? No. Okay, wait, give me a minute. Okay, so now am I audible to you? Okay, so let's begin again. What I was saying, guys, look at this very carefully, that if one component carries the electric field, other will carry the magnetic field, and the last component, which is this one, will have what? Electromagnetic field, or we can say electromagnetic radiations. Okay, see these perpendiculars, means these axes are mutually perpendicular to each other. So any one of the component can carry the electric field, anyone can carry the magnetic field, and anyone carry the electromagnetic radiation or electromagnetic waves. Okay, that's what this theory means. Is it clear to everyone? Now I'm going to draw this. Is it clear to everyone what I was trying to say? Okay. See, once again, look at this. This is your, once again, those who has got some doubt. See, these are three axes, x-axis, y-axis, and z-axis. Okay. I hope so everybody is clear that these axes are perpendicular to each other. Okay. So what I was saying, that if y-axis suppose carries the electric field, see, y-axis carries what? Electric field. This is the symbol of electric field. Okay. Z-axis carries the magnetic field. Okay. So what about the last perpendicular, means last axis? The final axis which is left will carry what? EM waves or radiations. Simply, I was saying this one. Now is it clear to you? Out of three axes, one will have electric component, other will have magnetic field component, and the next one will have what? Electromagnetic waves or electromagnetic radiations. Is it clear to you guys? Please copy this. Okay, so those who were making this symbol at that time can change this one. You have to take your words back now. Is it clear to everyone? Okay, cool. Please copy this. If anyone has still some doubt, please you can ask me. I can take another example if you want to. Okay, copy. Itanagar, is there any confusion or problem? Is it clear to you? Senapati? Senapati, where are you? Okay, so let's move on, guys. Okay, ठीक है सब ठीक है? Shillong? Okay, very good. So let's move on. I can see some of the students, they are just sitting, means they're sitting like this. The person in front of us is saying something and we are just listening from this ear and over. Guys, is everything is clear to you? Okay. Okay, so let's begin. There are few important things, some important terms. Definitions. First of all, wavelength. See, a wavelength is represented by the lambda. This symbol is known as the lambda. Okay? First of all, look at this. This is a wave. Okay? See, the upper part, I'm talking about this part. Okay? This is known as crest, whereas these bottom points are known as trough. Okay? The topmost point is known as what? Crest, whereas the bottommost point is known as what? Rough, which is rough or trough. Okay? Now, wavelength simply says that the distance between any two consecutive either crest or trough. Okay? If you have to determine the length of a wave, then you have to consider either crest or trough, consecutive to crest or trough. Okay? So, if I talk about this one, see, from this point to, one second, from this point to this point, this is what? Wavelength. Similarly, from this point to this point, this is also what? Wavelength. Okay, so I can define it as a distance between any two consecutive either crest or trough. Please copy. And one more thing you can copy is this one. See, the height of the wave is known as amplitude. This is known as amplitude. You can represent this by the help of A. समझ में आया? Okay, let's move on. Okay, so let's talk about its unit. SI unit is meter. But guys, the problem is we have to use some different units. Even in the questions, you will find some other units like micro, pico, angstrom. Okay, so to solve those questions, you have to convert them into meters. Okay, so I'm writing few important other units as well. Okay, so other conversions as well. So you have to just remember those. First of all is angstrom. This is equals to 10 to the power minus 10 meters. Then 1 picometer is equals to 10 to the power minus 12 meters. 1 nanometer is equals to 10 to the power minus 9 meters. 1 micrometer, this is the micro, is equals to 10 to the power minus 6 meters. These are few common terms that you will find out in the questions. Okay, so guys, remember that they won't mention their values. Okay, you have to remember these values. Okay, please copy this. And after that, next is frequency. Represented by nu. Can anyone please tell me what is the frequency? Frequency. Can you please tell me what is frequency? I'm waiting. If you don't know, you can simply say that, so we don't know. Okay, path taken by per unit of wave. Okay, this is one of the definition. Let's see. Anyone else? First of all, please raise your hand who suggested that this is the definition of the frequency. Please. Again, there was disconnected. Net was disconnected. Please, can you raise your hand once in the Shillong Center? Okay, 1, 2, 3. Wow. Okay, so let me start. Guys, listen to me very carefully. That how many waves can pass through a given point in 1 second is the frequency. Pick out any point. Okay. In that point, at that point, how many waves will pass in 1 second? That will be its frequency. Are you getting me? Are you getting me? That the number of waves passing through a point in 1 second. Okay. Only 2 students has got this concept. Wow. Do I need to repeat this? See, this is the definition, that the number of waves passing through a given point in 1 second. In 1 second is the frequency. Okay, frequency has a formula as well, that frequency is inverse of time period. Okay, frequency is what? Inverse of time period. Okay, yeah, inverse of time period. Okay, so let's move on. One more minute, please copy this, and after that we'll move on. Now is everybody clear with the frequency? Okay. Okay, so let's move on. Let's talk about the units. One is hertz. Okay, represented by the H and Z, or time inverse. If I talk about the SI unit of time, what is the SI unit of time? SI unit of time. Very good. So you can simply say second inverse as well. Okay. So let's move on. Next is wave number. Number 3, represented by nu bar. Okay. So wave number is what? Reciprocal of wavelength. Guys, one important thing, that the structure of atom has many formulas. Okay, many formulas. So please make sure that you will start practicing all these formula from the beginning of the chapter. Okay, you will learn all this formula along with me. Don't wait for the time that when structure of atom will finish, you will start learning them after that. Okay, it will be quite difficult at that time. So please do this along with me. Okay. Okay. So can anybody please tell me what should be the unit of wave number on the basis of this formula? What should be its unit? Can I say minute inverse? Can I say it should be minute inverse? Because a unit of wavelength is, yeah, very good. A wavelength of, what I was saying? The unit of wavelength is the minute. So obviously wave number should be what? Minute inverse. Okay. Can I move on? Okay, so let's begin. So guys, this is the first relation of the structure of atom. Relation between frequency and wavelength. See, this is C is equals to nu lambda. Okay, now what is C? Speed of light. And the value of speed of light is 3 into 10 to the power 8 meter per second. So we have to use this formula. We will practice 1 or 2 questions. Directly formula based questions are those. Okay. And then we will move on. So you can copy this formula please, and then let's start. Copied. Can I move on? Okay, see. First question. If time period for a radiation is 3 into 10 to the power 6 seconds, then determine its wave number. Copy this question and tell me the answer. My dear student, on the third bench, on my left hand side, who is talking to other three girls, can you please solve this question? See, I can see you. Timing's running out, guys. You're taking too much of time. Can I start if you have attempted this, or you need some more time? Okay, who has got this answer? Can you please share your name? Okay, he has got. What's your name, dear? The student who has just raised her hand. Wow, this is your name. 9 into 10 to the power minus 14. Because I got reply that when I asked your name. And who has got the previous answer? 1 by 9 into 10 to the power minus 14. Yeah, I know that. Okay, so guys, let's begin. See, we have given with the time period, which is 3 into 10 to the power 6. So we can get the frequency from here, that is 1 by 3 into 10 to the power 6. Okay, that's good. Okay. So we have got the frequency. Now what do we have to calculate? We have to calculate the wave number. But for the wave number we need wavelength. So first of all, let's calculate the wavelength. C is equals to nu lambda. We know this relation. So C is 3 into 10 to the power 8 and upon nu, which is 3 into 10 to the power 6 is equals to what? Lambda. So on solving this, lambda will comes out to 10 to the power 2. Now, wave number 1 by lambda, just 1 upon 10 to the power 2. Do I have made some mistake? See, time period is given to us. By the help of time period, I have calculated the frequency. See, formula. Frequency is inverse of the time period. Okay. After calculating the frequency, I have used this relation to calculate the wavelength because I need wave number. Wave number is inversely proportional to what? Wavelength. So wavelength will be what? This upon this. Okay. Oh, 1 second. 1 second. 1 second. 1 second. Yeah, that is inverse actually. 3 into 10 to the power 8 into 3 into 10 to the power 6. Yeah, I got that. I got that. So lambda would be 9 into 10 to the power 14. So wave number would be 1 by 9 into 10 to the power minus 14. Oh, this should be the answer. Minute inverse. This should be the answer. That was calculation error. Who has got this answer? Raise your hand. Who has got this answer? 1, 2, 3, 4, 4.5. And what about others? Okay, 5.5. Please copy this, those who haven't got the answer. Copied? Okay. Next question. How long would it take a radio wave of frequency 6 into 10 to the power 3 second inverse to travel from Mars to Earth? A distance of 8 into 10 to the power 7 kilometer. Do this question. Tell me the answer. Try to use physics as well. I mean some basic formula. Can I start? See, we are given with the distance 8 into 10 to the power 7 kilometer. Convert this into meters. 8 into 10 to the power 10 meters. We know that the time is equals to distance upon velocity. Okay. You have given with the frequency. There is no use of this frequency. We have to use this formula. Okay. Just put the values. See, all the radiations travel with the speed of the light. Okay. So distance that we have to cover is 8 into 10 to the power 10 upon velocity is 3 into 10 to the power 8. That's it. We have to solve this. There is no use of the frequency. You have to remember that radiations travel with the speed of the light. Please copy. Okay, so guys, let's start. Next is electromagnetic spectrum. See, what is the meaning of electromagnetic spectrum? The ordered arrangement of all the possible radiations on a screen, or we can say in an ordered arrangement actually. Okay, the ordered arrangement of all the possible radiations in the increasing either frequency or wavelength is known as what? Electromagnetic spectrum. Okay, so first of all, write down this one, that the arrangement obtained by arranging various types of EM waves in orders of their increasing frequency or wavelength. Okay, copy this first. Okay, so look at this. This is gamma X gamma rays First of all, let me draw this for you, and after that you will start copying this. Gamma rays, X rays, ultraviolet, then visible, okay. Please do not write like this, visible, okay, outside of the box. You have to write inside the box, okay. Visible. After that, micro, radio waves. One second. Infrared, micro, and then radio. Copy this, please. Okay, this is your electromagnetic spectrum. Please copy this first. Please write visible inside the box. Write visible inside the box. This is the wavelength. Means on moving left to right, wavelength is increasing. On moving left to right, wavelength is increasing. Okay. And one more thing, that in visible, we have got Vibgyor. Okay, so violet has the highest frequency and least wavelength among the Vibgyor, whereas red has got the highest wavelength and least frequency. You have to remember this one as well. Please copy this. Guys, you have to remember this one. Copied? Okay. So guys, look at this. I'm telling you a simple trick to learn that whole electromagnetic spectrum, because in the examination sometimes two, three radiations are given to you and you have been asked to arrange or find out the correct order for the arrangement. Okay, in the either in the form of wavelength or in the frequency. I hope so everybody is clear that frequency varies inversely with the wavelength. Okay, so whatever order we have got for the wavelength, to convert that into frequency, you have to just reverse that order. Okay, because they varies inversely with each other. So first of all, trick. Okay, just look at the screen. That Rawls please do not copy this right now, just look at the screen. Rawls' mother is visiting uncle Xavier garden. Okay, now I am highlighting these letters. Okay, now look at this. This is your radio wave, microwave, infrared, visible, ultraviolet, X-rays, gamma rays. Okay, so this is a simple trick to learn all this, but remember one thing. This is in the order of increasing frequency. See, this order is in increasing frequency. So please use this while writing the increasing frequency. Okay, so see, radio, micro, IR, visible, UV, X, and then gamma. Guys, this order is in the increasing frequency, not in the wavelength. Okay, so just learn this order in the Just learn this order and remember this is the frequency. Okay. To determine the wavelength, you have to just reverse order. Okay. So please copy this. Have you got this? Have you got this? Any confusion or doubt? Itanaga, are you there? Okay. So guys, you need some break for 5 minutes or we can carry on. Okay, cool. 5 minutes of break. See you in 5 minutes. Hi guys. So, how was your break? Have you enjoyed your break? Can we start again? That's good. Okay, so we have learned the trick. So, I hope so everybody now can remember the correct order for the electromagnetic spectrum without any doubt. Okay, so let's move on. Okay, so that's all about the electromagnetic spectrum and the electromagnetic theory. Okay. Now after that, the next theory is Planck's quantum theory. Planck's quantum theory. Okay, guys, listen to me very carefully. So first of all, who was Planck? So let us discuss about the Planck. So Planck was a scientist who gave this theory, and he simply said that. Okay, so please don't emphasize on the Planck that I have just said, that Planck was a scientist. That definitely he was. Okay, so this is the main point right now, which I am talking right now. That he simply said that anybody in this world will emit or absorb energy. Okay, that is energy in the form of packets. The student who is talking to their friends, can please look at the screen? Yes, I'm talking to you. Okay, I won't mention. Okay, so let's start again. So, Planck simply said that anybody can emit or absorb energy, but that energy will be in the form of packets. Now the word packet we are using here. Okay, so what is the meaning of packet? See, if I talk about packet, or let's say suppose packet of sugar, okay, and then packet is of 1 kg, okay, so what does it mean? That one packet of sugar will have fixed quantity, okay. So if I say that 10 packets, it means that those 10 packets have what? Fixed quantity, and they were countable actually. You can simply count them, okay. So this is what said by the Planck, that anybody will emit and absorb energy in the form of packets, okay. Packets have certain fixed quantity and value, and these packets have termed or named as a quantum. I hope so everybody has heard about quantum, okay. So these packets of energy are called as the quantum or quanta, okay. Quanta is a plural word, okay. And simply in case of light, if we talk about the light, these quantum are known as the photons, okay. So photons are simply what? Quantum, okay, which refers to the energy packets. So first of all, let me write this statement, and after that we will discuss little bit more. So please copy this along with me. That it states that anybody can emit or absorb energy in the form of packets. These packets of energy are called quanta, or we can say quantum. Okay. In case of light, it is known as photon. Okay, we can simply write the quanta, that is a plural word. Copied. देखो बेटा, जो लोग मेरे बोलने के बाद ही बात कर रहे हैं ना वहां पे, उनको पाप लगेगा, बता रहा हूं मैं. Guys, have you done that? Have you copied that? Okay, so let's move on. Okay, have you cleared with the term Planck's quantum theory? Planck simply said that anybody will emit, what is this? Okay. Anybody can emit or absorb energy, and to that one as well, who is beating the other guy? Someone is beating. Who is that? That Hinsak person? Yeah. Okay, let's move on. So, as said by the Planck, that anybody can emit or absorb energy, and these energy, or we can say this energy, will be in the form of packet. It means they have a certain fixed value. So, next thing that is said by the Planck, that the energy emitted or absorbed is directly proportional to frequency of radiation. Okay, so E is proportional to nu, said by the Planck, and after removing the proportionality sign, we will put a constant which is H. H is Planck's constant, and this is your formula. Guys, see, this is for exactly one photon, or we can say exactly one quantum. This formula is for one quantum. If there are n quantums, or we can say there are n photons, in that case you will use the formula E equal to n h nu, where n is number of photons. Okay. H is your Planck's constant, and its value is 6.626 into 10 to the power minus 34 joule second. Okay, copy this please. Done? Okay, so let's move on, guys. See, we have already seen this formula, C equal to nu lambda. Okay, so I can use this relation. We know that nu would be equal to C upon lambda. So after putting the value of nu in the previous formula, I'll have a new formula for energy, which is E equals to N hc by lambda. Okay. We have to use this relation, and we will solve few questions as well. Okay. I'm giving you first question. Please solve this for me. That a yellow radiation has wavelength 6,000 angstrom. Determine energy of radiation. Please answer this question. Nobody will use the calculator. Use your brain. Everyone has brain, na? There is a student at the last who is sitting like this. Dear, even you have to solve this question. Yes. Just enjoying the question, looking at the question. Okay, who has got this answer? Can you raise your hand, please? I want to recognize each and everyone. Who is Balajit? Raise your hand. Okay, you are Balajit. Here. Okay, good. Don't confuse me. Balajit has to raise the hand. Okay, there is another different answer. I think so. If I have give you 2 more minutes, I'll get 16 different answers. Can I start? Nafi has got some different answer. Okay, Annie and Iba has got some other different answer. Guys, I'm starting solving this question. Please look at the screen and let's see what should be the answer. Simply use the relation E equals to Hc by lambda because n is 1. Remember, whenever n is not given to you, simply assume that it is 1. Put the values and solve this. So E would be Hc, H is 6.626 into 10 to the power minus 34. C is 3 into 10 to the power 8 upon lambda is 6000 angstrom. So 10 to the power minus 10. Meters, you have to convert that into meters as well. So please just solve this. If I cancel out, this is 2000. This is 7, 15. So this is 3.313 into 10 to the power 715 minus 19 joules. Who has got this answer? Do I have made any mistake? Wait, minus 34, 15, yeah, 19. It should be 19. Is it right? Okay, who has got this answer? Who has got this answer? Please raise your hand. Okay. Only 1, 2, 3. Okay. So let's move on. One more question for you. A violet light has wavelength. Wavelength of 5000 angstrom, and red light has 8000 angstrom. Which one will have higher energy? Higher energy. Please solve this. Okay. Who has got this answer? Oh wow. Many of you has got the same answer. Congratulations. So, let's start. First of all, guys, this question should hardly take 30 seconds. Reason being, you need not to solve that. You have to just answer which one should have the higher energy. So, we know that E is inversely proportional to the wavelength. We can get this by that formula. Okay. So, we can see that violet has wavelength of 5000 angstrom and red has 8000. It means that higher the wavelength, lower is the energy, and lower is the wavelength, higher is the energy. So answer should be violet. That's it. How many of you has done this smart work? Can raise their hand. Those who has done this smart work. Okay, only 2, 3, 4, 5. Okay. So let's move on, guys. Next. After that, photoelectric effect. So guys, first of all, understand the concept of photoelectric effect. First of all, make these words clear that photo means light. Okay. So basically, due to the light, there will be some electric will happen over there. That's why this is the this phenomenon is named as the photoelectric effect. Due to the light, there is a flow of electrons, okay, which is termed as the photoelectric effect. Okay. So first of all, let's clear this concept, and after that you will copy this. See. Let's say suppose this is a metal surface. Okay. This is your metal surface. I'm not drawing the actual setup. Okay. Itanagar has sent lots of Ks. Okay. Let's start again. See, this is the metal surface and free electrons are present in this. See, these are electrons moving in random directions. Okay. Oh, it's okay. I was just kidding there. Don't take it seriously. Okay, let's get back again. So guys, we know that these electrons are still present on the surface. They are not ejecting or they are not coming out of the surface. Okay. So it means that there must be some energy which is binding these electrons, means they are able to move freely on the surface of the metal, but they are not much free to coming out of the surface. Are you getting this? That these electrons are moving freely on the surface of the metal, but these are not coming out of the surface. It means that there is certain energy which is binding these electrons on the surface. Okay. So that energy is termed as the work function and represented by the phi. Okay. So phi is the actual energy which is binding these electrons, which is actually not allowing them to coming out of the surface. Okay. Don't write anything about the work function or the this work function phi. Okay. I'll write it about this. After that you will copy that. Okay. So first of all, just make it clear that these electrons are freely moving in this surface. Now, what happened? That we use a light and allows them to strike the metal surface. Okay. We know that electrons, when get some energy, they will gain that energy and they will start moving in the same direction where they were moving initially, but the difference is this time they will they will move very fast. Okay, because they have gained the energy. So if I talk about this electron, see this electron, Obviously, its direction is towards the back side. Therefore, after gaining the electron, it will move in the current direction. If I talk about this electron will start moving towards the surface. If I talk about this electron, this one will start going towards the bottom. Okay. So, guys, remember one thing, by supplying the energy, there is no change in the direction of the electrons. Okay. Electron will carry their direction in which they were initially moving. But the difference is that this time they will move very fast. Okay. Let's say suppose the energy we have supplied is E. Okay. First of all, guys, clear one thing, that if I talk about this electron, see, if I talk about this electron, is it possible that in the current scenario this electron can come out of the surface? Obviously not, because this electron is moving towards the back side. Okay. If I talk about this electron, yes, this electron has got possibility to come out of the surface. Why? Because this electron has the direction towards the surface. Okay. So there is another important term, that to come out the surface from the metal, or we can say the emission of the electron, the direction of electron should be towards the surface. Okay. The free electron should move towards the surface. Okay. So all those electrons who are moving towards the surface will eject from here. Okay. And they will have a certain energy, and they are moving right now. That's why that energy is known as what? Kinetic energy. That energy is what? Kinetic energy. First of all, guys, I'm just summarizing it. Please listen to me very carefully and tell me, is it clear to you that I am saying that initially electrons are moving randomly in their directions. Okay, they cannot come out of the surface because there is certain energy which is present over there, that binds the electrons, that they can move freely over on the surface, but they can't come from that surface. Second, to emit those electrons, and for the emission we have to supply some energy, and that supplied energy is what? E. Okay. And after the supply of the energy, electrons will start coming out of the surface, and they will have the kinetic energy. Why the kinetic energy? Because they are in motion right now. Okay. So they will have the kinetic energy. First of all, please tell me, is it clear to everyone till now? Because after this, I'll write the phenomena. Raise your hand, Shillong. Who has got this? Who has got all this clarification? Okay. Okay, let's start. Guys, I am writing this phenomena, but before that, I'm writing something. That kinetic energy should be equals to E minus phi, and this is your max. How many of you think that this is right? Kinetic energy should be equals to E minus phi. Think about it like this. Think about it. Okay, leave that. Please copy. I'll discuss about it. See, photoelectric effect is not over yet. Okay, still it is remaining. First of all, I'm just writing the phenomena that I have discussed with you. Okay, that the phenomena of emission of electrons from the surface of metal when irradiation of suitable frequency strikes the metal surface. The emitted electrons are known as photoelectrons and current so produced is known as photoelectric current. Photoelectric current. Obviously, when electrons will move with faster rate, there is a production of current, or we can say there is a current that is known as the electric current. Okay, we'll discuss about it later on. First of all, I hope so. What I'm saying? Yeah, I hope so. Everybody is clear with the basic phenomena of the photoelectric effect. Okay, what is the meaning of photoelectric effect? Ultimately, the emission of electrons from the metal surface when we strikes photons to the metal surface is known as what? Photoelectric effect. This is the basic phenomena of that. Okay. So please copy this one and just inform me that you have copied that. Please copy this. I will discuss about this kinetic energy equals to E minus phi. But we can't discuss right now due to some time constraint. And guys, remember the redox reaction sheet has got approximately 100 questions. 4-5 questions are more than 100. So according to the calculation of 20 questions per day, I'll start from today. So it is 31st. Okay, sorry, it is 1st, not 31st. I think you should be able to solve all those questions or attempt all those questions by 5th of the October. Okay. After that, whenever we will have a next class, I'll take doubts of that sheet. Okay. So guys, please come with the doubts and attempt all those questions. Okay. That is for you. And after that, you have to attempt the NEET questions as well. Okay. So that's it for today's session. So guys, it was nice time with you. See you next time. Till then, take care. Bye-bye. Have a great time.